Hello, you glorious Godot people. Jan here from Canopy Games, and I wanted to take a quick look at the new Navigation Agent 3D and the new navigation system in Godot 4 Alpha 3. Now, everything you're seeing here is subject to change. Godot is not in a code freeze yet for version 4, so this is really just a quick behind-the-scenes peek as what's happening right now. When I say behind-the-scenes peek, I'm not working on this. I am not part of the Godot engine team. I do teach Godot. You can check out our courses at canopygames.com, link down in the doobly-doo. But I enjoy this new system. I think the new navigation system is awesome and way easy to use. So let's take a look. I've created a quick, simple scene here. In it, we have a floor, which is a static body. I'm using the static body so I can get this input signal here on floor input event. And I've got a CSG combined 3D, which has got a bunch of boxes in to make these outer and inner walls, all of which have collision in it. I also have a character, which is a rigid dynamic body 3D. That's the new version of the rigid body 3D. And it has a mesh instance, a collision shape, and a very, very simple script that just holds the idea of a destination, which is defined as a vector 3, and the constant of speed. We're going to be moving at a constant speed. Now, one more thing I've got is I've got a camera and a ray, and I should just make sure that the camera and the ray are in the same place. They are not. That's going to be important in a minute. The reason I have this is when I run this, at the moment the level has a script. When I click somewhere on the floor, you can see the coordinates of where I've clicked. What's happening here, and you can get the documentation of how to do this in the Godot docs, I've got the camera and the ray, and when we get the signal that we've clicked on the floor, we check, is the input a mouse button? Are you pressing? And is it the left mouse button? In other words, if the floor has detected that you've just clicked the left mouse button, then the ray cast is going to move to where the camera is, and it's going to set its target to where that position is. And the way it's doing that is the camera is casting a ray on where the click is, so event position, and the ray length is 1,000, which should actually be ray length. I don't know why I did it that way. Let's make it nice and simple. So we're casting a distance of 1,000 away from where the camera is. So 1,000 meters from the camera is, and that's going to be the ray. We're now forcing the update. We want to do it in this frame, not the next frame. That's very important. Then we're just saying that our destination is where the ray is colliding. So get the first collision point. I'm also setting the height as 1 meter because we don't have any other heights going on. And we're just printing the destination. We're going to be changing that in a moment, but just to show you how that works, we go in here, we click, and as long as we're clicking on the floor, we can see where we're looking. If I click on the wall or elsewhere, or I do a right mouse button or the middle mouse button, nothing happens. Great. So the first thing I want to do is I want to bake some navigation in. I'm going to add a navigation region. Navigation regions are part of the new navigation server system. The nice thing about navigation regions is you can have multiples, and if they touch, they will just work together. I'm going to move it up here, and I'm going to move both the CSG combiner and the floor to be a child of navigation region. Now, you'll notice this little error here. We need to actually create our navigation mesh, and I'm just going to bake it. Boop. There is our navigation mesh. Now you'll notice that we can't actually get to all the places, so let's just change that a little bit. I'm going to go to Agent, change the radius to, let's say, 0.75. I want it to be slightly bigger than the character. There we go. The character has a radius of, what is it? A radius of 0.5 meter. So a diameter of 1 meter. I want this to be slightly bigger than the radius because I don't want them caught in the corners. Okay, so we now have a working navigation mesh. And it just works, so that now works. Great. So now we need to make the character work. To do this, I'm going to add a brand new node type, which is a Navigation Agent 3D. Now, if I look at the documentation for this, it'll do a lot of fun stuff. Now, we're not going to worry too much about things like agent height offset. We need to ignore Y to be on, but there's 2 key things we want. We want set target location, and we want set velocity. We also are going to need is target reachable. So let's start there. Is target reachable? Returns to if the target is reachable. In other words, if you can get there. If there is a navigation mesh where you've clicked, go there. If there isn't, if you're too close to the wall, we're going to ignore it. Set target location is going to set the user's final location, and it's going to clear the current navigation path. So none of this creating our own array of paths and doing it all manually and getting the next point and removing it. We're just going to set the navigation path, and set velocity sends the path and velocity for the collision avoidance algorithm. We're not actually using the collision avoidance algorithm, although we can take a look at that at the end. But that's how we're going to use it, or that's how it would work rather. Otherwise that sentence makes no sense at all. And that's really all we need to do. So let's start using that. So we're going to make a new function, and we're going to call it set destination. It's going to take an argument, which I'm going to call new destination, which I'm going to try and spell right. There we go. And that's going to be a vector 3. I'm just going to use some strict typing in there. Okay, first thing I'm going to do is set my current destination to be my new destination. And now I'm going to say NavigationAgent3D dot set target location destination. Okay, so now the navigation agent is going to clear its current path, create a new path there. Okay, so let's get that actually working. I'm going to check this every frame. Now, normally I would use physics. So physics, there we go, process delta. However, I'm not going to do this for here. And here's why. If I right click on here and look at the documentation, one of the very first things you get told is don't change a rigid dynamic body's 3D position every frame or very often. Sporadic changes work fine, but physics run at different granularity, yada, yada, yada. In other words, I shouldn't be using physics process. Instead, I'm going to use integrate forces, which has an underscore. Let's try that one more time. Integrate forces state. Now, I'm not actually going to refer to the states. I'm going to put an underline there. And let's do some checking. So first, if navigation agent 3D dot is target reachable. In other words, if you can get to the new target, now I'm just going to set where we should be going. So let's make a variable called target, and I'm going to use NavigationAgent3D dot get next location. What's get next location? Well, let's take a look. Returns a vector 3 in global coordinates that can be moved to. Awesome. In other words, it's just the next place in your path. It's going to handle all of that for us. So we're just going to say go to the next location. And we need our velocity, don't we? So let's say velocity is equal to where we are now. So global transform dot origin dot direction to target. Let's make this nice and big so we can see what we're doing. Great. Okay, so we've got the velocity, and I'm going to normalize that. And I want to add in my speed, or multiply my speed, not add it. There we go. So we're going to get the direction we need to be moving to, and we're going to get the right speed. Okay. Now, I'm going to use NavigationAgent3D's set velocity. Now, I don't have to do this, right? It's pass velocity as an argument. I could instead just do this, linear velocity, or set linear velocity. Velocity. However, if I want to use the built-in obstacle avoidance, which we're going to do in a second, and to use it properly, I need to run a signal from the navigation agent. So let's go here and get velocity computed. Boom, and it'll give us a safe velocity. In other words, how fast or slow do I need to be going to avoid the obstacle this frame? So now let's go set linear velocity. Safe velocity. Awesome. Okay, let's make this actually work. And instead of printing the destination, I'm going to get to my character, and I'm going to use set destination, and type in my destination. Before we go any further, a couple of things I want to check. First, I'm going to go to my character and say, if you're not reachable, let's stop moving. So else set linear velocity vector 3.0. Okay, and also I probably want to put some axis locks on. I don't want this thing rotating, so let's put those on. And let's press play. And I can click around the place and select brand new places to go. Look at that. Let's go over here. So we now have a simple little navigation system, which at the moment I'm using to click to move the character. Now, I mentioned obstacles, so let's put in an obstacle. Let's put in a brand new rigid dynamic body. And did I? Radius is 0.25, radius is 0.25. Wonderful. One more thing I'm going to do is I'm going to add in obstacle. There we go. So it has a navigation obstacle, and that's all I need to do. So when I put that in, the player is now going to try and avoid this obstacle. You'll see right here, it's trying to find a way around it. Look at that. Now, it is assuming this obstacle can move, which is why it's slowing down like that. If I click over here and put it that way, so what I'm going to do is I'm going to give this some physics. Let's go to new physics material, and let's make it very, very bouncy. Maybe 1, not 10, and with very little friction. Okay, one more time. And there you have it. We have a little bouncy ball that the character is going to try and avoid. We've not put any real AI in and stuff. This is just a very, very simple demonstration of how it's working. But this is the new navigation system so far in Godot 4, and I have to say I'm really impressed. I think everybody who's worked on it has done a fantastic job. It's a lot simpler to use. It's very, very versatile. And because you can now bake navigation at runtime, which you couldn't do before, you can easily make changes to the level and see how it goes. Are you going to sneak past? You can sneak past. There we go. So, thank you for joining me. Do check out our courses if you want to see more stuff, free and paid, or check out our YouTube channel for our weekly live stream and little clips. Meanwhile, thanks for joining us, and I'll see you soon. Bye!